Hello students, welcome back to NCERT Line by Line YouTube channel. Today we are going to continue the lecture Chemical Reaction and Equation. So in the previous video we learnt about what is chemical reaction. So what do you mean by chemical reaction? If at all there is any chemical change has occurred, we can say chemical reaction has taken place. So whenever there is a chemical change, we can say chemical reaction has taken place. We also learned different examples for chemical reaction. So one of the example is spoilage of milk during summer. It is a chemical reaction. Also rusting of iron. When you keep it in the humid atmosphere, iron will get rusted, right? So it is also an example for chemical reaction. Also fermentation of grapes, burning of paper, all these things are examples for chemical reaction. We also learned the difference between physical change and chemical change. So what do you mean by physical change? In physical change, no new product is formed, whereas in chemical change, new product is formed. In physical change, it is usually reversible in nature, whereas chemical change is irreversible in nature. Examples for physical change, if I take one rod, this is not a rod, this is a pen, and I bend the rod. Now, can I again get back the straight rod? Yes, I can. If I put some strength, I can get back to the original rod. Whereas, if I burn one paper, I am taking one paper and I am burning it. Can I get back to the original paper? No. Once you burn it, it gets converted into ash. Ash, again, you can't get back to original paper. So, it is a chemical change. So, chemical change is irreversible, whereas physical change is reversible. We also learned about one activity, that was burning of magnesium ribbon. So when I take, there was one question in that, one important question, that is, when you burn the magnesium ribbon, you usually clean the magnesium ribbon and then you burn it. So what is the reason for this? So in magnesium ribbon will react with air and form magnesium oxide layer. So the magnesium oxide layer cannot react with oxygen. So what we will do, we will remove that layer and then we will burn. So what we will get? Magnesium oxide. Okay. In this video, we will learn two more activities. In the first one is reaction of lead nitrate with potassium iodide. So what they are telling is, they are telling us, I will take one sticky note. Okay. What they are telling is, take lead nitrate solution in a test tube. Now this is a test tube, okay. This is a test tube. Okay. So this is a test tube. So what they are telling is, they have taken lead nitrate solution. What is lead nitrate? PbNO3 twice. So they have taken lead nitrate solution in a test tube and they are adding Ki, that is potassium iodide. So what will happen? When they add potassium iodide to lead nitrate solution, so let's see what is the reaction. So PbNO3 twice reacts with Ki to give lead iodide plus potassium nitrate. So if I want to balance, this is 2 and this is 2. So in this reaction, what they are telling, what do you observe? So when the potassium iodide is formed, this is bright yellow precipitate. Bright yellow precipitate. Okay. So what will happen? A bright yellow precipitate will be formed. So this is our observation. So question can be asked, right? What is the color of precipitate? And it is not given in the textbook, but what you will say if it comes to exam, what you will say? Okay, it is out of syllabus. No, it is not out of syllabus. It is inside the syllabus, but they have not given the answer. They have just given it in the activity blog, which you need to learn. Okay. So what will happen? A bright yellow precipitate will be formed. Okay. This is the first activity they have told. There is one more activity that we will learn. What I'll do is, I'll take one more sticky note. And okay. So what they are telling is, here you can see the activity. So what they are telling is, you add some zinc granules. Take some zinc granules. Granules means small pieces. Small pieces of zinc is taken in a conical flask, and you will add a dilute H2SO4. Dilute H2SO4 is an acid, right? So what will happen? So the reaction goes like this. Zinc Zn reacts with dilute H2SO4 to give zinc sulfate, that is ZnSO4 plus H2 gas to be liberated. This is H2 gas we will get. So this is a reaction for the formation of H2 gas. Again, with this a little bit heat is also liberated. The reaction liberates heat. Now I'll just remove it. 1 minute. Just remove it. So they have given here, see. So what they have given here, from the above activity, what we can see, there is a change in state, right? Whenever there is a chemical reaction, there can be change in state. Like solid is getting converted into gaseous state, or liquid getting converted into gaseous state. So there is a change in state. True. There is change in color. We saw like lead nitrate solution. When we add potassium iodide to it, to the lead nitrate solution, what will get? Yellow precipitate. So there is a change in color. Evolution of gas here. H2 gas is getting liberated. Change in temperature. Again, this same reaction which we saw just now. Heat is getting liberated. There is a change in temperature. Initially it was cool, then it gets little hot. Okay. So all these things are we can observe in a chemical reaction. That's what they are trying to say. Now let's go to the next section. So what are chemical equations? So what do you mean by chemical equation? Chemical equation is a way to write chemical reaction. Okay. The simplest method is to write as it is. Like magnesium, you write the name, entire magnesium reacts with oxygen to give magnesium oxide. You will write the entire sentence. Okay. This is the simplest way to write the chemical equation. In the left side of chemical equation, it is known with the equation, or the components that is undergoing reaction are called reactants. The product which you are getting is product. That is after the reaction which we will get is product. Okay. We have learnt about magnesium reacting with oxygen, that is magnesium ribbon. We are burning the magnesium ribbon to get magnesium oxide. So what will happen? Magnesium reacts with oxygen to get magnesium oxide. So you can directly write in this way. So the left side is known as reactant and the right side is known as product. So we will indicate this arrow. What does this arrow indicates? It shows the direction of reaction. So magnesium reacts with oxygen to get magnesium oxide. So it is the direction of the reaction. Okay. So where the reaction is going. So left side is known as reactant, which is undergoing reaction, and the substance that will get after the reaction is called product. So we will separate the reactants with plus sign. So magnesium plus oxygen. Magnesium reacts with oxygen. The arrow signs indicates the direction of the reaction to get the product, that is magnesium oxide. Okay. Okay, this is one way. There is one more way, and which we will usually use because it is very difficult, right, to write magnesium MAGNE. Why will you write like that? It is impossible. Now the reaction is very small, so it feels okay, it's easy. But when you get more reactants and more product, it's very difficult to write the entire thing. So the other thing which we can use is chemical equation. To write the chemical equation is, we'll see. So the one more method, and it is a shorter method to write chemical equation, is using chemical symbols. Okay. So for magnesium we use Mg. For oxygen we use O2. So Mg plus O2 is MgO. This is the left hand side. This is right hand side. So what is there in left hand side? Reactants. reactants is in left hand side, and in the right hand side we get product. So magnesium reacts with oxygen to get magnesium oxide. So the plus indicates, so the reactants are separated by plus, okay, plus symbol, and the arrow symbol indicates in which direction the reaction is going, and the right hand side what we will get is the product. Is it fine? So this is the easier way to represent a chemical equation using chemical symbols. Okay, now if you see, it is not balanced, right? See here oxygen is 2, here oxygen is only 1. So we need to balance this chemical equation. Whenever you are writing a chemical equation, you should always balance the chemical equation, otherwise it's a wrong method, right? Without balancing a chemical equation we should not write, at least in exam you should not write. So this is 2, this is 2 again. So this is it for today's video. In the next video we will learn how to balance a chemical equation. We will learn the easiest method available to balance a chemical equation. It is not random method. It's a proper mathematical method which we are going to use, and it is one of the easiest method. I'll make sure everyone will get full marks in balancing chemical equation. Thank you, students.